Hello, everybody. I hope you all had a happy new year. And to continue the fun, we have this nice fitting integral right here that we're gonna evaluate. So let's continue in the celebrations and let's get started, shall we? So, to begin with, you'll notice that we have this 2024 up top, which, well, let's see how we're gonna deal with that. But first, we're just gonna start off with a pretty simple, just a U sub. Nothing crazy yet. So we're just going to let u equal the natural log of 1 over x. And just to simplify things, just properties of exponents, just negative natural log of x. Now we see to find du. So du equals negative dx over x, meaning that our dx is just equal to negative x du. All right. Just gonna throw all this in real quick. We'll do the bounds next. So we just have u to the 2024, and then a negative x du. So we need to do two things real quick. First, we need to change our bounds, and then we want to sub in our. I'm going to make that x in terms of u. So let's start with the bounds actually. So our bounds were from 0 to 1. So what I'm going to do is just take u of 0 is we're going to get the natural log of 1 over 0. That doesn't quite make sense, but if you take it as in the limit, as we approach 0 from the right, what we actually get is just positive infinity. So just think of the graph of 1 over x, you get something like this. We're just going to approach positive infinity. And then you take the natural log of that. Limit is still just going to be infinity because the natural log does that. So this actually just approaches infinity. And then u of 1 is actually quite a lot simpler. So u of 1 is just natural log of 1 over 1, which is just natural log 1, which is by definition 0. So we have our bounds from infinity to 0. It'll look nicer in a second, don't worry. The second thing we're going to do is just, we're just going to solve for x. Nothing crazy. So I'm just going to exponentiate both sides. It's probably a better way to say that. That's okay. And then take the inverse of both sides, so we're just going to have x equals e to the minus u. So now we have our integral from infinity to 0 of u to the 2024 of negative e to the minus u du. I am just going to pull this into minus sign out and use it to swap the bounds. So what we actually have here is from 0 to infinity of u to the 2024 e to the minus u. Now, some of y'all might recognize this as just being the factorial function, or the gamma function. Same thing, more or less, just shifted over. So we could just kind of skip here and go to the answer, but that's no fun, is it? So let's try to do this using integration by parts to kind of prove that this actually is a factorial function. So yeah, let's get started. I think this calls for a color change as well. Okay, so basically what we're going to do is, again, just integration by parts. So we want to differentiate this side, and we want to integrate this side. Meaning that we're going to have integral from 0 to infinity. Or well, that should be an integral, should it? We're just going to integrate this side. So we're going to have negative u to the 2024 of e to the minus u evaluated from 0 to infinity. If you take the limit as this goes to infinity, this would go to 0. But if you plug in 0, that's also 0. So this whole term right here is actually just 0, meaning that the integral is just equal to, well, we need to differentiate this now. So we're going to have 2024 times the integral from 0 to infinity of u to the 2023. So last year, man. To u, or e to the minus u, du. And, well, that looks awfully, does look like this, that looks the same, doesn't it? Like, those are basically the same. So, what if we did it again, right? So this is just going to be equal to, again, just integration by parts, 2024 times negative u to the 2023 e to the minus u, evaluated from 0 to infinity. Again, that's just 0, so we're just going to have our extra integral term here. This time, instead of 2024, it's just going to be a 2023 because we're differentiating. We have a 0 to infinity. That's not an infinity. There we go. Okay. 2023. We have a u to the 2022, which is the very last year. E to the minus u du. And again, this term is just 0 here. So what we have here is just for 2024 times the 2023, and then times our integral of u to the 2022 e to the minus u du. Well, if we just continue the pattern, eventually we're just gonna get down to where this right here is 0, and the integral from 0 to infinity of e to the minus u du is just, that's just 1. Like that as an exercise for the viewer. So the only thing that's actually going to affect our answer here is we're basically just going to get repeated powers brought down when we differentiate in integration by parts. So what this is just 2024 times 2023 times 2022 times 2021 dot 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 all the way down to 1. And that right there is just 2024 factorial. So there we have it, this nice little integral right here to celebrate the new year. This right here is just equal to 2024 factorial. Alright, hope y'all enjoyed, and I hope 2024 is off to a great start for y'all. Thanks for watching.